This is a video about interfaces. So this right here is kind of a classical example of interfaces. We have a guitar amplifier. So this thing's an antique. It even has antique dust on it. It's got vacuum tubes in it. And we want to know how to connect this amplifier to a loudspeaker. So I have this tiny loudspeaker right here. We wouldn't really use this, but it's small enough that I could hold it for this video. And you'll notice the back of the loudspeaker says it's an 8 ohm speaker, and it has a 0.5 watt power handling ratio, meaning that it could absorb up to 0.5 watts from the source. Now, how would I connect this to this amplifier? And is even a reasonable thing to connect? So the amplifier has a set of terminals on it. Right here, it has 2 terminals on it. It's a 2-terminal device. And then you'll notice the speaker has 2 terminals on it that are going out to the twisted pair, which was cut off of another EK307 project. So how would we connect these things? Well, we just physically wire them together. And we could do that, but more importantly, are they compatible? Will they talk to each other? And you're taking circuits right now, you might think, well, maybe I could analyze it. Like what's going on inside that amplifier. Maybe I could just simply use mesh equations and KCL and KVL to figure out what's going on and model that loudspeaker as the 8 ohm resistor that they claimed it is. Now if we look inside the amplifier, that might be kind of daunting. See all those parts in there? So these are all resistors and capacitors, and those bias to vacuum tubes which are sitting on the back of this right here. And these 2 tubes right here are the power output tubes. Those are doing the amplification, and it goes through this thing right here. This is an audio transformer that basically changes the impedance, the high impedance of the tubes, to be able to drive a low impedance loudspeaker. And we don't know if our loudspeaker has the proper impedance, which is 8 ohms, to connect to the terminals on the back of the Gibson amplifier. And just by looking at this, I'd say that is a daunting, tall order to mathematically figure out how to make these 2 things work. So that's where things like Thevenin equivalence come in. And so you learned in lecture that, if you're lucky enough, you could model a circuit, even if it's very complex, if the circuit is linear enough, as a voltage source and a resistor right there. And these 2 terminals right here are the terminals on the audio amplifier. There's 2 terminals right there, and they're tricks that you could use to measure these parameters, these Thevenin parameters, to get a linear model of the amplifier. And the speaker claims to be an 8 ohm speaker, which is somewhat true. We'll take it on face value right now. And there are 2 wires on our loudspeaker, and literally we want to know, how do these 2 devices interact when we connect the wires up, right? Like if I wired those 2 things in right there, is this amplifier going to work? Is it delivering the maximum power to the speaker or not? So because the speaker looks like an 8 ohm resistor according to the back, we could put an 8 ohm resistor in here. Now, what we want to do is figure out what RTH and VTH of the amplifier are, and when we know that, we could figure out the amount of power that's being delivered to the 8 ohm speaker. And that power is converted to acoustic sound that radiates out of the speaker. And how we're going to do this is subject to another video, but I just want to introduce this concept of interfaces. So this can apply to all different things. This could be some big power supply, and this right over here could be a load, like that might be the power grid, and that might be your city, or it could be something like a loudspeaker. It could even be a model of something like blood circulation through the body, where the V would be the equivalent of a pressure, and RTH is inherent losses in the heart, and this resistance right here represents all the fluid resistances of all the blood vessels. So this is a really universal concept. It gets used in all kinds of engineering applications.